So we're very fortunate today to have Randy Nepresh as our speaker. He's a stormwater regulatory specialist with Stantec, and he works with the Minnesota Cities Stormwater Coalition. Those are cities regulated under the Stormwater Permitting Program, or the MS4 program. And he has a lot of experience advising public and private agencies on TMDLs, low impact development, and alternative stormwater management. He's very highly regarded in his profession and received a major award in 2014 as Professional Manager of the Year by the Water Resources, for Water Resources by the American Public Works Association. So we're really honored to have you here, Randy, and it's a pleasure. If you'll go ahead and share your screen, I think you can get started.
There we are. You should be seeing my slides now. Excellent. Hi, everyone. Thank you for attending the seminar. It's a real pleasure to be doing this. My name's Randy Nepresh. I am speaking from Roseville, Minnesota, so only a couple miles north of the St. Paul campus. You can see here the title of my presentation. I should also introduce, it's almost inevitable that there will be dog barking in the background. His name is Zeke, and no web event is complete with a certain amount of dog barking. You may see a cat behind me at some point, and his name is Charlie. And every web event is improved by having a cat involved. So now introductions are complete. Oh, that's interesting. You're seeing my first slide. Are my slides changing, Dave?
No, they're not.
Oh, excellent.
Just minimize and see if we can do it that way.
No, it's not working at all. I'm gonna stop sharing and start sharing again. Try it on another platform. Go to the slides.
We can see the slides again.
Okay. Hey, and there it's changing. So I wanted to start. This is a list of most of the people from the University of Minnesota that I have had the pleasure of working with over the last several years. It is carefully presented in reverse alphabetical order. And it should be noted that tall Bruce Wilson should never be confused with short Bruce Wilson. I wanted to say what a pleasure it has been to work with all of these folks, how much I admire their work and how much their work has contributed to moving stormwater forward in Minnesota after the last several years. As far as I'm concerned, this seminar is the house of these folks, and I'm honored and privileged to be invited to speak here. I also wanted to comment on the passing of Roger Bannerman recently. Roger did a huge volume of brilliant work in the state of Wisconsin, a good bit of it in research, but then also using the research to inform the development of many of the stormwater regulations in the state of Wisconsin. I can't think of a single person who's made a greater contribution to moving stormwater forward. So Roger will be missed. And then there's my introduction. The sum total of my academic background is a bachelor's degree in civil engineering. So I'm going to guess that you all are taking a big step downward in terms of the academic prominence of your speaker today. I am, though, a professional engineer, been doing it since 1992. I work for a consulting firm, Stantec Consulting, with an office in downtown Minneapolis. But almost all my work, especially in the state of Minnesota, is as a staff person under contract for the Minnesota Cities Stormwater Coalition, which is about 130 of the cities in our state that are regulated under the MS4 permitting program. And I'm going to spend a good bit of time talking about that. I am also the vice chair of the National Municipal Stormwater Alliance. We refer to it as NAMSA. And for a portion of my talk, I'll be speaking from the national perspective, and that's mostly from the NAMSA work. There are some themes for the presentation today, and I'm going to refer back to them, but I'd like you to keep them in mind as I prattle on. One is, we're definitely talking here about urban stormwater. It ain't ag, it's not rural, it's what's going on in cities. Stormwater is simply not well behaved, is a polite way to put it, especially compared to wastewater and drinking water. Anybody who's done monitoring work will know this well from the stormwater field. Stormwater is also the youngest of the public water infrastructure sectors. That's a significant factor. Also, as a sector, in a number of ways, we are deficient in important aspects. And at the end of the presentation, I'm going to talk about that. We still have a lot to learn about stormwater, what works well, what's cost efficient. This is linked back to the notion that it's not well behaved and it's still relatively new. All this stormwater work is quite complicated, but this presentation has to be pretty short and simple. So I'm gonna just touch on some topics pretty briefly, but please feel free to ask questions and probe more deeply after we've talked for a bit. So the first fundamental question is stormwater actually important? I, of course, am going to say yes. It is, according to US EPA, the leading source of water pollution in the United States today. In large part, that's a tribute to the fact that we've done a really good job addressing water pollution from wastewater plants and industrial plants. It's the only source of water pollution that's growing today. It is the source of many water quality impairments throughout the United States, but also we know how and we are capable of resolving many of the problems and challenges, which means that our work is worth doing. There's a good chance that good work will be productive and useful and actually result in water quality improvements and protection, which is a good thing. So way back when, stormwater was written into the 1972 Clean Water Act, arguably one of the most important and effective pieces of environmental legislation in US history. We didn't really know what to do about stormwater back there. So everybody essentially pretended that it wasn't written into the Clean Water Act, and not much happened. Along came a number of lawsuits by environmental groups in the 80s, basically telling EPA they couldn't pretend that it wasn't there. And things started to happen in terms of stormwater regulations. So now what we have, emanating from the federal level but administered by states, are three major programs for stormwater regulations. Industrial sites are regulated for their stormwater runoff, distinguished from their processes. Active construction sites are also regulated. And then finally, we have the MS4 permitting program, which stands for Municipal Separate Storm Sewer Systems. In the regulatory world, our intention is to abandon English entirely and move to nothing but acronyms, mostly so that nobody else will really know what we're talking about. But in the meantime, MS4 permits take two forms. There are phase 1 permits, which cover large cities, which have individual permits. In the state of Minnesota, only the cities of Minneapolis and St. Paul have phase 1 permits. The phase 1 permitting program came online in the early 1990s. Then there's the phase 2 program. That covers small and medium-sized cities. Those cities are covered under general permits, and the first of those nationwide was written in 2003. In Minnesota, we have one general permit that covers about 170 cities and another 70 or 80 or so other non-traditional permittees. Department of Transportation, prisons, the University of Minnesota, multiple campuses are MS4 permittees. Nationwide, we have about 7,500 MS4 permittees, and about 6,500 of those are cities. So it's a lot of permits and a lot of cities that are covered. It's an unusual form of water quality permitting. When you think of wastewater treatment plants or industrial processes, those are numeric permits. They have single pipes, usually relatively consistent discharge that's easy to measure and to control, and none of that is true in stormwater. So the MS4 permit is non-numeric. Instead, it's based on best management practices or stormwater control measures. Those BMPs or SCMs can be structures, things that are built in the ground, but they can also be programs or practices. Street sweeping, leaf pickup, public education, training for builders and contractors, all sorts of things. One way to look at it is EPA and the states are telling the permittees, go forth and do good things. The regulators will provide some information and lists of good things to do. They'll provide some performance standards, but each permittee is left to decide the appropriate mix for their jurisdictions. And then we assume that if these good actions are implemented, they will result in water quality improvements and protections. Some people refer to this as faith-based permitting. Another way to look at it is there's a message to MS4 cities, MS4 permittees in general, from EPA and the states, which is, we want you folks to think and act. This is not actually quoted from anywhere. This is just me talking. We want you to think and act seriously about stormwater in the course of building things yourselves, but also in the course of regulating new development and redevelopment by private owners within your jurisdiction. We want you folks to become local stormwater regulators. And this is essentially what's happened. The foundation of the MS4 permitting program is these 6 minimum control measures: public education, public participation, illicit discharge detection and elimination, stuff that shouldn't be in stormwater systems ever, local construction site stormwater runoff control, post-construction stormwater management, all the stuff that's left in the ground after the new development or redevelopment project is done, and then pollution prevention and good housekeeping for municipal operations. Again, many of these are things you would not see in a water quality permit for a wastewater treatment plant, for instance. The legal standard for MS4 permits is maximum extent practicable. You should know it takes a year or two of practice before you can say practicable reliably and consistently. Written into federal rule in 1999 at the beginning of the phase 2 program, EPA wrote, this is quoted from the rule, EPA has intentionally not provided a precise definition of MEP to allow maximum flexibility in MS4 permits. Another quote from the rule: EPA envisions application of the MEP standard to be an iterative process. What this means is that the permit requirements are always becoming more stringent and more demanding on the permittees. So this shows you a couple things. One is it describes in part why MS4 permittees are a tad more nervous than most permit holders. But it also reflects some of the themes I mentioned earlier. This is the kind of permit you write for a medium that is not well behaved, that is not well understood. And it demonstrates the expectation that we are going to learn as we go along and then write those lessons into MS4 permits. Most states throughout the country have delegated permitting authority from US EPA. In Minnesota, that's the Minnesota Pollution Control Agency, the MPCA. But these programs are highly variable from state to state. There are some states that have hundreds of staff people. There are other states that literally have 2 or 3 people that run their entire state program. And then finally, many MS4 permittees are linked to total maximum daily loads, TMDLs, quantified pollutant load reductions for specific impaired waters. And when the permits are linked to TMDLs, they suddenly become somewhat numeric. Like I said, it's highly variable. Here's 3 examples of areas in the country that have very active MS4 permitting programs. One is California, where everything is amazingly expensive. Their permits are very complex. They are highly prescriptive. Most of them are driven by litigation, lawsuits from any number of different parties. Another area of the country is the area covered by the Chesapeake Bay TMDL, where that TMDL has acquired a lot of attention. It's been in place for a long time, and there's been a meaningful response from the states and the permittees in that drainage area. Another example are cities like, specifically actually, New York and Philadelphia, that had consent orders from EPA in reaction to combined sewer overflows. And each of those cities made huge commitments to build and implement green infrastructure at a meaningful scale throughout their jurisdictions. In each one of these cases, we're talking about expenditures in the billions of dollars. In Minnesota, it's rolled out rather differently, and for a number of different reasons. Arguably one of the foundations of all the work here is that Minnesotans genuinely love our water. And we have been willing collectively to commit our money to protect it. That's reflected in decisions and actions by cities all over the state. Compliance has generally been good, largely voluntary. Permittees have stepped up to do the work that was expected of them. I can also say that the MPCA has done a good job with this permitting program. They have staffed it at an adequate level. They've done a good job at stakeholder engagement, greatly appreciated by the cities that I work for. They've written reasonable permits, and they've also offered useful tools and guidance to the permittees. I would commend to you particularly to take a look at the Minnesota Stormwater Manual. It's really a remarkable document and one of, if not the best, stormwater manual in the country. Some other things that happened. The MS4 cities formed a coalition, MCSC, which I have had the pleasure and privilege of being the staff for the last 18 years. Most of the MS4 cities in Minnesota now have stormwater staff and good local construction site programs. The Minnesota cities have almost all developed and implemented effective local stormwater design standards that meet the MS4 permit requirements. Minnesota has more stormwater utilities at the local level than any other state in the United States. It's something like 198 of them, I believe, last time Western Kentucky University looked. That's not on a per capita basis. That's just an absolute number. We've got more stormwater utilities than a lot of states that are much bigger than us. Another factor here in Minnesota has been the work of watershed organizations. A few of them are covered by MS4 permits, but most of them aren't, and most of their good work in terms of water quality is taking place outside of the permitting program. And then we also have state-of-the-art, especially at a national level, stormwater research led by the University of Minnesota and this unique organization, the Minnesota Stormwater Research Council. Wonderful stuff. So one of the interesting things to look at is if you have a new regulatory system, it's useful to look at older existing regulatory systems to see if there's one that's similar or analogous. I'm going to suggest quite enthusiastically that the place to look is not wastewater or drinking water, but building codes. So here's some characteristics. Building codes are not numeric. They're based on best practices. We know how a house ought to be wired, and we're going to expect you to do it right. We know how to build safe and durable buildings, and it's recognized that this is the responsible thing to do. On the stormwater side, we know how to do development and redevelopment in ways that protect downstream waters, and it's simply the responsible thing to do it. The building code is extremely complex, but builders and designers have simply stepped up and learned how to work within it. The building code changes as we learn what works and new techniques and products come to the field. Compliance with the building code is expensive. It costs a lot, but it is universally recognized that it's the right thing to do. Compliance with the building code depends mostly on good training, good intentions, and local inspections. There really isn't a whole lot of enforcement that goes on. If something's wrong, you just have people fix it. Retrofit is rare. The building code is usually enforced at new construction or when there's significant reconstruction. And then part of the structure is that local regulations control construction by private owners. All very similar to the MS4 permit. With all that said, I want to move on to the national level and talk about the National Municipal Stormwater Alliance, NAMSA. Excuse me, we're still pretty young, all of 3 or 4 years old. We're incorporated as a nonprofit. We have an executive director, Dr. Seth Brown, and I helped found NAMSA, and I'm currently the vice chair, as I said earlier. We are a national alliance comprised of and focused solely on MS4 permittees. We have 2 types of members. One is state and regional coalitions of MS4 permittees, like MCSC. And then we have affiliate members. Each of our state and regional members represent at least 5, in most cases, many more MS4 permittees in their state or region. And our affiliate members are consultants, technologists, manufacturers, and other folks that are focused on the MS4 sector. We have 22 current member states. They're all the states that are in blue here. And then we have active conversations going on in the other states that have plus signs. They're just, all these state level organizations have risen organically within their states. And there simply seem to be some states where such organizations have not yet been formed or coalesced. Our goals: we focus on MS4 permitted related issues and concerns, and we build on a detailed, on-the-ground knowledge and understanding of how local MS4 programs work. I've seen comments at the federal level by other national organizations, and they don't bring this level of focus and detail to the comments that they're providing to EPA or Congress. We're determined to be accessible and valuable for both phase 1 and phase 2 permittees, not just the big cities. We want to engage and be useful for the small and medium-sized cities as well. We want to represent the maturity of the stormwater sector in terms of money, staff, and effectiveness. Like I said, the sector is new, but we're growing up, is the best way to put it. We want to begin to match drinking water and wastewater, the older and much more mature water infrastructure sectors at the national level in terms of institutional structures and funding. So some examples of our work. The American Society of Civil Engineers, every 4 years since the early 80s, I believe, put out something called the Infrastructure Report Card. This gets a lot of attention everywhere around the country. It is enormously influential in Congress. Drinking water and wastewater have always been specific categories or sectors within the Infrastructure Report Card. In 2021, the new report card will have a new category, stormwater. That represents about 2.5 years of work on the part of NAMSA. Some other things, we have a good website with resources and information. You can just Google the name and we're the only thing that'll pop up. We have worked to get a categorical exclusion for stormwater control measures written into the new Waters of the United States definitional rule so that constructed stormwater ponds are not listed as impaired waters, something that just doesn't make any sense at all. We started work on that in 2014. We've worked with the Water Environment Federation on their MS4 needs survey, the second edition of which is to be released soon. We've worked on giving a ready-to-go, shovel-ready project list to Congress in the event that they're actually successful in putting an infrastructure funding bill together. We work with EPA on the 2021 Clean Watershed Needs Survey coming up next year, and then also the report of their Stormwater Funding Task Force. And finally, on this list at least, ASTM, the international source of standards, has just recently formed a new stormwater committee. We've been working on that for a while. We find ourselves at an interesting crossroad. I describe it as both exciting and terrifying. There's important work that needs to be done. It is consequential and impactful. Every time we turn around at the federal level, we're looking at legislation or programs that are dealing with hundreds of millions of dollars, levels of funding that stormwater programs have rarely, if ever, seen. The stormwater sector needs this work to be done in order to continue to grow and mature. The work is complex and demanding, but doable. At the same time, though, it is mind-numbingly boring. This is what the term "in the weeds" was invented for. If you ever want to add true excitement to your life, take a look at the Federal Register or take on a 400-page bill in Congress that's written mostly for the Corps of Engineers. And as NAMSA works diligently to try to do this work, we're doing it with very limited capacity. You remember, we're really young and all of our local members are already stretched just to be able to meet their permit requirements. So we just don't have much in the way of money and staff resources. So the last piece in the presentation is a discussion of what's missing in the stormwater sector. I talked about it being young. I talked about how we're all still learning things. We also have these important gaps. In many cases, information that we really ought to have that we just don't have. And in some cases, we don't even know how to collect. Nobody's ever done it before. So one of the most important things is cost data. What's the investment in stormwater, both in terms of structures and programs and practices, both on the public side and the private side? You would think we would know that, but we don't. How much does it cost to comply with the MS4 permit? This one kind of blows me away. I mean, we're talking about major regulatory agencies, US EPA, the state Minnesota Pollution Control Agency. They are promulgating a permit program, and yet no one knows what the cost of compliance is. We don't have a real solid handle on how much all this additional stormwater stuff affects housing costs. You know, just like adding seatbelts and airbags to cars increased the cost of automobiles, all this stormwater work also increases the cost of houses everywhere. This information is 1/2 of the cost efficiency equation. I'm going to talk about the other half in a minute. This sort of data is going to be needed for the federal 2021 Clean Watershed Needs Survey. That survey will be much stronger if we actually have this data in hand. And then finally, every other major infrastructure sector knows this information. Transportation does a great job of knowing how much is invested in roads and bridges, and they use that information all the time with legislatures and Congress to promote programs and funding. We don't know the environmental outcomes of our work. This is the other half of the cost equation. How much are we actually improving water quality? To what extent are we protecting water quality? And then we can compare that to the cost to get it done, and we can measure the bang for the buck for the work that we're doing. It would be important for the MS4 cities to be able to quantify and tell the story of the good and important work that they are doing. It's a lot of work and it should be a good story, but we need this quantified information in order to tell that story well. We need to do a better job of quantifying the benefits and providing regulatory credits for new techniques. Couple examples here. Street sweeping, something simple, not sexy like green infrastructure. We've been doing some great work led by the University of Minnesota over the last several years looking at street sweeping. Turns out street sweeping picks up a lot of phosphorus, removes a lot of it from the system, and does it at certain times of the year. We're looking at removing phosphorus at the cost of $100 a pound or more. We have places here in Minnesota, other places in the country, where we're looking at costs more on the order of $5,000 to $20,000 a pound to remove phosphorus. This news on the street sweeping side ought to be a big deal. We're working to try to make that happen. Another example is large, long-lived urban trees. Turns out they do terrific things for stormwater management, but they also improve air quality, mitigate heat island, sequester carbon, promote human physical and mental health. They have economic benefits. They address environmental justice issues. And yet trying to pull all those benefits across multiple regulatory systems has proved to be just about impossible to do. We want to see better support for stormwater research. This is an item that's particularly popular with the University of Minnesota faculty. We need a good national strategy. We need to improve stakeholder engagement on this at the national level, and we can use the Minnesota Stormwater Research Council as a model. We need much better systems of technology transfer and information diffusion. We need to translate the results of good research that's being done and get them to local practitioners in a form that is useful and actionable for them. That's the whole point of all that work. We also need to better disseminate. As we do this work, we're learning important lessons, but we don't have good systems for disseminating those lessons to the thousands of practitioners around the country. NOAA's Atlas 14 looks at precipitation frequencies. We need to regularize the schedule for updatings for these precipitation frequencies. We literally went 60 years without an update. This is, how big is the 100-year storm for the city of Minneapolis or the Twin Cities area? In this age of climate change and non-stationarity, we just can't afford to have those updates go so long in between each edition. We also need to have it funded at the national level. Right now it's done regionally, and the work should be done at the national level instead of region by region around the country. We also should be seeing more source control to get and keep many chemicals and pollutants out of our stormwater systems. We should elevate stormwater in the eyes of Congress and state legislatures throughout the United States. Again, get stormwater closer to being equivalent to wastewater and drinking water, bring real funding to the sector, provide meaningful support for stormwater research. And then finally, arguably most important, we need to increase the understanding and support for stormwater work in the eyes of the public. And with that, I am done and would welcome questions, please. This also is I'm also showing my email address, and folks should feel free to get in touch with me, please.
All right, first question is from Philip.
Yeah, you talked about the credit system, and I know that Minneapolis through Chapter 54 has a similar credit system for industrial and commercial buildings. I guess my question is, when you're regulating it through BMPs for like water quality standards and TMDLs, how do you get those commercial and industrial sites to update their BMPs to reflect changing water quality standards and TMDLs? I know they do that now with, I think, volume control and rate control, and that subsequently has some kind of connection to water quality through that. But how are you guys doing that on a national level, getting some of those older sites that might have been grandfathered in with their BMPs, even if those ordinance updates or I guess standards are changing? How do you get them to, I guess, improve their BMPs?
Sure. Yeah. No, that's an excellent question and a complicated one. I need to start by saying there are credits and credits. Minneapolis has a quite large stormwater utility fee, and their local crediting system actually, if a good-sized industrial site puts in stormwater BMPs, they can get a reduction in their monthly utility fee on the stormwater utility side. So that becomes a useful and important incentive. And we've seen some really impressive work done by some industrial facilities in order to reduce their fees. That, however, is not the crediting system that I was talking about. Let's say a way to look at this is we have a total suspended solids TMDL for Lake Pepin. The drainage area for Lake Pepin is a good bit of the state of Minnesota in land area, and something like 75% of the population in terms of MS4 permittees. The permittees now have to track the reduction from all their stormwater BMPs for total suspended solids in order to show progress toward meeting the TMDL requirements. So the more types of BMPs where we have quantified the benefits and provided credits for the implementation so that each city doing that type of BMP can report the BMP and claim the credit under the TMDL requirements. That range of BMPs expands slowly, but it does expand. It needs to expand faster, and we need to try to pull more different types of effective BMPs into that crediting system, because that crediting system becomes the incentive for cities to build those sorts of devices and have other people build those sorts of devices within their jurisdictions.
All right, thanks. Trevor asked 5 questions. I'm going to read them. I'm going to read them to
Excellent.
you sort of one by one. I think 2 of them can be combined. The first question is about stormwater and drinking water infrastructure, which is built a long time ago and under massive cost shares from the federal government. So the first question is, how much is it going to cost to replace all of that infrastructure? How long is there to actually make those changes, and how are we going to pay for it?
If I understand that question, it's totally unfair, because I can't tell you much at all about how much it's going to cost to replace drinking water and wastewater infrastructure, other than what really counts, which is it's going to cost a whole heck of a lot. We have some similar stuff on the stormwater side. We have old stormwater systems, and it's going to cost us a lot of money to replace, repair, and keep those maintained. But then we're also building new stormwater systems, and many of the things that we're building, green infrastructure as an example, requires a good bit of operation and maintenance. So every time we build something, there's the capital cost, but we're also taking on really significant O&M costs, otherwise known as costs that go on forever, every time we do that. And you shouldn't underestimate the scale that we're talking about. We've got one city in Minnesota that has more than 800 rain gardens. So we're talking about big numbers, large costs. The question kind of brings up the good old days when the feds actually helped pay for wastewater and drinking water infrastructure in a big way. We haven't seen those days in a long time. There's still a good bit of federal money that goes to those sectors. There's very little federal money now that goes to support stormwater. And one of our missions in life is to rectify that situation. So that's as close as I'm going to get to answering Trevor's first question.
All right. The second question has to do with the factors relating to climate change. So, as you know, the existing infrastructure was built for a climate that no longer exists. And so how are we going to manage public expectations regarding the failure of those as our climate gets wetter? And you talked about the Atlas projects. I know in Minnesota, most of those were recently updated, but he's also asking whether we should start writing our 2050 or 2100 Atlas stormwater amounts today, so we can get ready for the future and begin actually planning today's infrastructure for the future.
I love the fact that Trevor's asking very simple and questions that are easy to answer. Climate change, on the stormwater side, what we're seeing on climate change is somewhat more rainfall on an annual basis, seeing it already, and it's projected, of course, to be more so. And then more of that rain is coming in intense storms. Stormwater systems are interesting. A lot of times people just think about the catch basins, the pipes, now the rain gardens, infiltration structures, even stormwater ponds. The catch basin and piping system is essentially designed to handle up to, say, the 5 to 10 year storm. But good engineers have designed those systems to be able to handle much larger storm events. Means we're going to see some backup, but it's going to happen in safe places. We're going to see stormwater in large events carried in streets and held in parking lots. We build emergency overflows for things like stormwater ponds to handle the 500 to 1,000-year storm. So in a way, our systems are built to handle the larger stuff. But we should be looking at what's going to come next and where the weak points are. You know, in any system like this, you're going to have some places that are quite durable. You're going to have other places that are going to not be able to handle the additional flows. And we're going to see real problems there. And it would be nice to be able to anticipate them and address them in advance instead of waiting until after the catastrophes happen. Atlas 14 is now 7 years old in Minnesota. Our last update was 2013. We have a number of cities that say cities that have full system hydraulics and hydrology models for their stormwater systems, but they have not updated those models to the Atlas 14 numbers. There's like 8 different reasons why that makes sense. It ought to be done. And it'd be nice if we could find ways to support cities in doing that. That, though, just brings us up to relatively current historical data. The notion, though, is once we do the update to Atlas 14, it's relatively easy to do the next update, which would be for projected numbers. One of the problems is we don't have authoritative design storm numbers for different regions around the country. You see all these different scenarios and probabilities, and those are the kind of things that city decision makers who have to allocate funds between a really broad range of multiple demands really can't handle, and the engineers have a hard time processing as well. So it's an interesting challenge. Let's put it that way.
All right, I'm going to combine his last 2 questions. They're both about specific pollutants. The first pollutant is PAHs, like the coal tar sealants that are banned, at least on driveways and sidewalks, but they're still used in roofing. And so is there a need for a total ban on coal tar sealant in Minnesota? The second question is about chloride. And again, that's very problematic to aquatic life. And our cities right now dealing with mitigation of chloride pollution in a very effective way.
Yes. Also good questions. I'm going to start with chloride. So chloride is tough. It moves across the surface really quickly and easily. It's always dissolved, and it moves through soil into groundwater with hardly any mitigation absorption on soil particles. So it's a real challenge. That arguably is the poster child for what I was referring to in the term source control. The best way to deal with chloride is to reduce its usage on roadways, rather than trying to build a bunch of stuff in the stormwater system to deal with really large amounts of chloride that are in the stormwater systems. We're making real progress on that, and a lot of cities are responding. The state, the PCA has done excellent work in terms of tools, information, and guidance, and we're getting there. PAHs are another example, or another case. This is an example of how we learn things in stormwater. So we built stormwater ponds were the first stormwater management technique we had. And we built them by the thousands, going back to the 70s and 80s. We thought we knew how they worked, but it turns out they had some surprises waiting for us. Not surprisingly, every stormwater pond fills up with sediment over time, needs to be dredged at some point in time to restore the depth and get the water quality function back again. What we started to find a number of years ago was in those dredged materials, we were seeing high levels of polycyclic aromatic hydrocarbons, PAHs. teratogenic, mutagenic, carcinogenic. There's probably 3 or 4 other genics in there as well. Bad stuff. And it turned out we're finding it with some frequency. And where we find it, the dredge material has to go to a lined landfill. So now a $25,000 dredging project becomes a $300,000 dredging project. You then do what's called courageous multiplication. Turns out partly because of this, we had everybody count their ponds. The MS4 cities had something like 14,000 constructed stormwater ponds. So take that cost differential and multiply it times, say, 25% of 14,000 ponds, and you're up into billions of dollars really quickly. And that's just a situation we can't handle. So one of the things that we did was we found the largest source was coal tar sealant on driveways and parking lots. That's where it's used. It's not used on roadways. And after a good bit of work, we ended up with a statewide ban, a wonderful thing. We are one of 2, maybe 3 states in the country now that have actually done this. Is a big achievement. And it turns out a really rare achievement, which is really unfortunate for a whole bunch of reasons. And perhaps we'll end up with a nationwide ban someday, but who knows when that'll happen. Another thing for NAMSA to work on. PHs in roofing, I hate to say, is a new notion for me. And now I'm gonna have to get in touch with Trevor and ask him about it.
All right, and Randy, Rich Axler sent you a message about watersheds, and I wanted to follow up on that a bit. I've been a watershed commissioner locally, and so we deal with projects, approving projects that come before our boards, and they always, in their permit have to mitigate stormwater runoff to a certain extent based on model predictions. And so on a project by project basis, we often go through all those details of the calculations to see if the pre-construction runoff has been adequately, mitigated in the post-construction scenario. And usually, by building those stormwater detention ponds and other measures, you can do that. My question though, is nobody's looking at the watershed and the cumulative effect of all of those projects over time. Isn't that something we should be doing?
That one's easy to answer. Yes. And my question, of course, to you will be, who do you think will do it? Cities do it to a certain extent in the case where they, for instance, have full system models, but frequently, almost always, a city's jurisdiction doesn't match a full watershed's jurisdiction. So then we have watershed districts, unique, wonderful things in Minnesota. And arguably that seems to be a function, and to the best of my knowledge, a number of watersheds have taken on that function. Interestingly, we are starting to see research on this. We've got a body of research looking at types of best management practices and specific installations to see how effective they are, what happens to them over time, all those sorts of things. I'm now seeing research being done where the scientists are looking at the impacts of what they call stormwater networks. So essentially, it's an entire system of various types, and in some cases, significant numbers of best management practices across a landscape, frequently a watershed at some scale. So I think we're making some progress toward that, but it's certainly important stuff and something that needs to be done.
Thanks. Any last questions? If not, let's give Randy a big hand. Thank you, Randy. It was really wonderful.
My pleasure. Thanks for
Thanks,
the
Randy.
opportunity.